Hello and welcome to this video on Apache Kafka. Now this is going to be a brief introduction as to what the Apache Kafka project is about, some of the different ecosystem components and APIs that are part of the project. So let's get started with what we have for you today. Now before I proceed, if you find this video helpful, please feel free to give it a thumbs up. You can also subscribe to my channel if you find this video helpful and you would like to get similar content in the future. And if you also found it helpful, please feel free to share it to others that you think will benefit from the content of this video. So to get started today, the Apache Kafka project is an open source project. It is a distributed project that allows you to perform event stream processing, which we're going to discuss what that is about in the future. Now, it also provides the framework for you to do high performance data pipelines that would allow you to set up streaming analytics for different projects where you can do data integration and enrichment. So I'm going to briefly cover what all these different terminologies are about briefly. So now to get started, Kafka is typically used for event streaming, but what is typically involved in event streaming? With event streaming, you typically capture data from different sources in real time as they occur, and then once the data is captured, it is stored in Apache Kafka in a way that is durable, also in a way that it is going to be efficient for you to retrieve it and process it in a way that can scale horizontally. Now, it also supports the ability for you to perform real-time reactions to these events as they come in, or you can also come back retrospectively and process these events after they have occurred. So that's all possible with Kafka. Now we can also retrieve the data from the Kafka broker, manipulate it, drop some of it, add some content, enrich it, and then put it back into Kafka before going ahead to route it to the different destination technologies, workloads or data stores that you intend to use in your particular project. So this is a typical summary of what event streaming is usually about. So now, how does it work? So this is the high-level architecture. Now you typically have different entities or processes that are generating these events. Now the event will be produced or written into the Kafka topics that are in the Kafka broker. And then you can now use different technologies like Kafka streams or Kafka or KSQL DB, and, which will allow you to retrieve the content that is stored in the broker, perform your manipulation by either filtering, enriching the different events or data records, and then putting that back into Kafka so that different consumers can now come into the Kafka topic, pull these events or records out of Kafka, and then either perform some action on it or go ahead and push it downstream to different data store technologies that are expecting the record. So this is typically how it works. You have something that is writing or producing the events. You have something that is performing a different process or system that is processing these events by doing filtering, enrichment, and any of those different actions on the records. And then you have a different set of systems or processes that are going to now come and pick up these records and push them to different destinations. So in real life, what are some of the different use cases for this technology? So you have the financial services that are using it in banks and the stock exchange. You have healthcare organizations that are using Kafka to monitor what is happening in intensive care units and also processing patient records in real times, also processing their claims for insurance purposes and things like that. You also have in agriculture, Kafka can be used to provide a framework for automating irrigation, animal husbandry, and all those different things. In IoT, we also have Kafka being used to streamline the process of doing data capture and processing as it happens in real time. We also have in retail Kafka being used to provide real-time recommendations, also monitoring inventory levels so that if something is out of stock, you can find out in real time so that the suppliers can know when to replenish the inventory and when to place new orders and all those different things. So it is very useful as well in surveillance to capture pictures, capture videos, and react to those content in real time as well. So what is the typical setup of an Apache Kafka cluster? Now in this diagram here, you have the Kafka brokers, which is where the topics do exist. And then you have Zookeeper at the very top of the diagram that is being used as a mechanism to track metadata as it relates to the Kafka cluster. So the offsets in the cluster for the topics, the topic names, and all the different configurations pretty much are stored inside Zookeeper. So Zookeeper at this very moment is a huge dependency for the Apache Kafka project, but the project is planning of separating Kafka from that other project very soon. So hopefully maybe this year in 2021 we'll be able to get rid of Zookeeper as part of the Apache Kafka cluster setup. So once the cluster has been set up, you have the metadata from the broker stored inside Zookeeper. You can now start pushing data into the Kafka cluster. So that is typically done by producers, which are writers into the Kafka topics in the brokers. So the producers would send messages into or events into the Kafka cluster. You can also have Kafka connectors. So the Connect API and the Connect ecosystem provides us with the ability to pull data out of different data stores into the Connect process, and then the Connect process now serves as a producer that will push those events into Apache Kafka. Then on the other side, you have consumers. So consumers are those different processes that would pull data out of the Kafka topic and then either consume it, take some action on the record, or push it downstream to some other destination technology. Similarly, like how we have the Kafka source connector, we also have the sync connector, which is a consumer that will pull data out of the Kafka topics and then push it downstream into a destination data store or technology. Now, the Confluent organization, they have an open source project that is called REST Proxy. So REST Proxy provides you with a REST API that allows you to interact with Kafka brokers using the REST protocol, HTTP protocol to do that. You also have the schema registry, which is kind of like an index or list or database of all the different data structures that are stored inside the topics. So Kafka today pretty much allows you to use any kind of data format, but what the schema registry supports is JSON. It also supports protobuf or protocol buffer. It also supports Avro. So if you have data in any of these different formats, you can use the schema registry from Confluent to keep track of the different schemas and data structures for those topics that are being created inside the Kafka brokers. Now, for processors, we have Kafka Streams and KSQL DB. So Kafka Streams is available in Scala and Java, and you can use it to pull data out of Kafka topics, perform some manipulation, and then push it back into the Kafka topics. Either the same one or most likely it's going to be a different one. Similarly, with KSQL DB, you don't have to use Java or Scala. You can use SQL to pull data out of the Kafka topics and also push it back into Kafka once enrichment and manipulation has been completed. And then you have the different sync connectors that pulls data out of Kafka so that it can be routed to one or more destinations. And you can also have the consumers, which would either terminate by consuming the records, or you can also push it to another destination. So at a very high level, this is a typical setup of what you would have in your Kafka cluster. So you have different components that are pushing data into Kafka, different components that are consuming data out of Kafka, and there are some that are just performing enrichment and manipulation of that data set. And right now, Zookeeper is being used to manage the state of the cluster, and the schema registry is an open source project from Confluent that is used to manage and to keep track of the different data structures for the data that is in the topics. So at a very high level, this is what you would expect when you're setting up your cluster. How is data stored inside the Kafka cluster? So data is stored in what is called partitions. So the data is going to be stored in a topic, which will be equivalent to a table in a relational database. Now this topic is further broken up into one or more segments called partitions, and then when data is being written, it is routed to one of these partitions, and they are stored in sequential order in which they arrived on the topic. And then when you have the partition can now be replicated to other brokers within the cluster for durability, and it is always guaranteed that the data will be stored in the order in which it arrived at a particular partition. So typically Kafka stores data in key value pairs. So the record or the event is going to be the value, and the key would be what allows you to route the data to a specific partition. Sometimes you may pick something that is unique to the particular record, and this will allow you to make sure that the same key always routes data to the same partition when data is being pushed into the Kafka topic by the producers. So in terms of APIs that are available for the Kafka project, we have these major ones that I'm going to discuss shortly. The admin API is used for administration of pretty much topics and things that are going on inside the Kafka broker. So you can use this to list the topics, to create topics, to manipulate the configurations of the topics, to delete the topics, and pretty much do anything you want to do with the topics inside the Kafka cluster. Now it can be used for other things, but typically that's what I use it for in my projects. We also have the producer API, which allows you to generate events and then push these events into the Kafka topics. So producers are typically writers that push events into the Kafka cluster. And then you have the consumer API that allows you to read out of Kafka and then consume those messages by either terminating at that particular process or pushing it downstream to another process. So producers are writers and consumers are readers from the cluster. Then the Kafka Streams API is something that allows you to pull data out of Kafka in real time and then process it, enrich it, and then put it back into Kafka. So it has different data structures, it has different mechanisms for you to do this very efficiently and in a way that is very easy. So finally, we have the Connect API, which is broken up into two categories. The first category corresponds to the producer, which is the source connector that allows you to push data into Kafka by pulling it from different data sources. And then the sync connectors allows you to pull data out of Kafka and push it to different destination technologies. So that's pretty much everything I had for this video. Again, if you like the video, please feel free to give it a thumbs up. You can also subscribe to my channel and also share the video if you think it was beneficial to you and you have others that will benefit from it. So that's all for today. Thank you very much, and I will see you in the next video.